So let us discuss the phasor diagrams now. The very first phasor that we have shown is of unmodulated carrier signal. So this is my original carrier signal which is generated by the crystal oscillator. This can be taken in the form of cos 2 pi fct. So cos 2 pi fct is represented with this vertical phasor which is pointing in upward direction. Now if you remember, we are passing this cosine form of the carrier through 90-degree phase shifter. There was 90-degree phase shifter block, which is this. Output of the 90-degree phase shifter is in the form of sine. So when you give 90-degree phase shift to this phasor, it will turn towards left and this is what you get. So this is nothing but 90-degree phase shifted carrier, and when I say 90-degree phase shifted carrier, it is nothing but in the form of sine 2 pi fct. Once we have 90-degree phase shifted carrier, we can now draw output of the product modulator or balanced modulator. So output of balanced modulator. Now I repeat, balanced modulator is nothing but the product modulator that we had here. So this is the balanced modulator or product modulator that we are talking about. To this we are giving the modulating signal in integrated form obviously, and the 90-degree phase shifted carrier. Now forget the integrated modulating signal and 90-degree carrier. To balanced modulator we give a carrier signal and a form of modulating signal. And we know that output of any product modulator or balanced modulator is always double sideband signal, which will be upper sideband and lower sideband. So considering that point, you can see that output of balanced modulator is always DSBSC. So double sideband suppressed carrier means you can see the carrier is suppressed. So this dotted line represents the original 90-degree phase shifted carrier, but it is suppressed now and hence it is no more present in the output of balanced modulator. These two phasors that we have shown are nothing but upper sideband and lower sideband phasor. Upper sideband phasor will be present at Fc plus Fm and lower sideband will be present at Fc minus Fm, where Fm will be the modulating signal bandwidth or maximum frequency in the modulating signal. So this is my output of the balanced modulator with two sidebands and carriers suppressed. You can see that there will be some specific phase difference between the two. It's something that we have shown. The total phase difference between upper and lower sideband will be maintained to 90-degree. So now if I draw the resultant sideband, the resultant sideband can be drawn using this rectangular law. What I've done is I've drawn a rectangular with the help of two phasors, and this diagonal will be the resultant sideband. So I can call this as resultant sideband phasor, which will be my output of the balanced modulator. Later on, we are adding the original carrier with the output of the balanced modulator. So this is the output of balanced modulator. Let me quickly also show the resultant sideband part. This is the resultant sideband part, and this will get added with the original carrier which was in this vertical fashion pointing upward. So resultant sideband and the cosine form of the carrier are added. So this will be nothing but my output of adder block. So now what will be the resultant? So this both are perpendicular to each other. So again, if I consider the rectangular form, the resultant will look something like this. This is my resultant phasor. This is cosine form of the carrier, and this is resultant sideband, which was output of the balanced modulator. So this represents the resultant phasor of output of the adder block, and whatever will be the phase difference between the original carrier and the final output will be nothing but phi of t. Because if you observe, my original carrier is Vc cos 2 pi fct, and output of the adder is nothing but Vc cos 2 pi fct plus phi of t. This phi of t is integration of m of t further. So the difference is phi of t, which is very small, and that's how this whole thing represents narrowband FM. Later on, we pass it through mixers and multipliers to increase the modulation index and also the frequency deviation of the FM signal. So that's Armstrong method, which is indirect way to generate FM signal.